Hello, in this video we're going to have a general understanding of exponents, and in here this means repeating multiplications in terms of the same number. Either the number can be a fraction, rational number, all kinds of numbers, decimals, and this here we're going to look at it in based on various examples. Now an example using numbers show here says that we have 2 times 2 times 2 times 2. This shows repeating multiplication, and in this case here one number is repeating is 2, and that means that we're going to write this here to be equal to 2 as the big number, which represents the base. And then how many 2's are you multiplying? In here we have 1 2 3 4. We have 4 here, and therefore our exponent is going to be represented as the number which is 4, and that is what this means in here. Looking at the exponent, the exponent tells you how many of the base you're multiplying in here, and that is how it is shown based on numbers. Now we can use this based on letters, and using letters will enable us to show the rule, and from the rules we're going to apply those two numbers. Now looking at the rule, the first rule here, we're going to look at a scenario where you have the base to be the same. In this case we have two bases here and they are multiplied together, and each base here has exponents that are either different or the same, which in this case represented as variable m and the other n. Now please make sure that you know that a are the same letters, or in this case numbers, and so when you're multiplying the same base, what that results in is the following. What we do is we keep the base and we do what to the exponent? We add the exponents together, and so what that results in is a simplified version, which means that you are going from a broader expression to a simplified expression, and this can be solved later to get your final answer. Now example of the first rule is shown right here, the first one, which shows that we have 2 to the power of 3 times 2 to the power of 4. Instead of use expanding this in such a way that you have how many 2's here, we have 3 2's here, and then you're multiplying it by how many 2's here, which is 4 2's. Then it means that we have to multiply all these 2's together and we get our final answer using expanded form. But instead of doing this, what we can do is the following. What we do is we first see that the base are the same. That means we do the following. We are going to keep the base, and what we're going to do to the exponent, in this case we have our 3, we're going to add the exponent because you're multiplying same bases, and so this results in the following, which is equal to 2 to the power of 3 plus 4, which gives you 7. Now next question here shows us a fraction as what the base and the base are the same, so this here is equal to what? Half as the base, and then our exponents of the bases are the following. We have 3 and we have 2. Because you're multiplying the bases, that means that you're keeping the base, and next final step is to add the exponent, which is 3 plus 2, and this results in the following for our base to be the same, which is we have our half, and we have 3 plus 2, which gives you 5. And so this here is a simplified version. You can continue further, and this will lead us to one of our rules for the next step involving fraction. Now the second rule here is going to be divided into two parts, and what do I mean? The first part here shows us that where we have our a, of course, as the base divided by the same base, in this case a, but our exponent here is going to be m and the other one here is n. There is a condition here that we need to take here into account. First condition is that, hey, first is that a must not be equal to 0, that is first, and second condition here states that m is greater than n, and so what that results in this particular second step here, or second rule, shows us that yes, that we're going to keep the base and this here because they are the same, But here, because we are dividing the base, we're going to keep the base, but we're going to do what to the exponent? The opposite of what we did for the multiplication, which is instead of addition, we're going to subtract the exponent. And so what that results in is m minus n. And this here is case scenario number 1 for law number 2 or rule number 2. Now, however, when you're looking at the other case scenario where we said, of course, that our a must not be equal to 0, but here we have our m to be less than our n, what results in this particular form is that our answer is going to be in this following expression, where our a is going to be kept because our base is the same, but our exponent is going to be what? It's going to be n minus m. But what is happening here to the general expression here? What is happening here is that we're going to have a condition that it must be a reciprocal as our value, because we want our exponent to be a positive exponent. And so what that results in is that we're going to have our overall expression to be the denominator, and we're going to put our 1 above it. We're going to see examples of how this here applies and the reason for this. Now, for rule number 2 here, our first case scenario shows us we have our base to be the same, which in this case we're going to keep the base. However, what we have is that we are dividing here, so therefore our exponent here is going to be 5, but we're going to minus 2, and this here is going to show us that yes, that our base is going to be kept, and our exponent, we're going to do subtraction, which results in the answer to be 2 to the power of 3. Now this can be proven, of course, by showing it in expanded form, where we have 2 times 2 times 2 times 2, and we have one more 2 here, which is 5 2's, and below we have 2 times 2. But what results now is that we are eliminating 2 2's at the top, at the numerator, and we're left with this here, which is equal to what we have here. So that is something to keep in mind in this scenario. However, the other case scenario is a proof that it is going to be different from what we have for case 1. And so for case 2, we have our base to be the same. So that means that this is equal to keeping the base. But here we have our exponent, which shows us that, hey, we have our exponent 2, which is m, to be less than 5. So that means we're going to write 5 minus 2 first. And what that results in as our exponent is this. However, we know that because our m, which is our numerator exponent, is less than the denominator's exponent, we're going to put our reciprocal. Well, so this here is going to be 1 over this expression. And so what that results in is the following, where we have our 1 over, we have 2 to the exponent of 5 minus 2, which gives you 3. Now, how can we prove this using the expanded form? We can prove this by showing that yes, our numerator, which is, we just have 2 2's, and we are multiplying them together, but this here is divided by, we have 5 2's, and this here shows us that when we eliminate the 2's at the bottom, we have what, 3 2's left. And so these 3 2's here reflect the denominator here, and we have our numerator, which is times 1, which is reflected here at the numerator. So this here is a proof that this here indeed works and is correct. Now the third rule states that when you have a power, in this case our base a, and our exponent here to be m, and in this here we have it all in parentheses, and we have our n. What this actually means is that when you remove the parentheses, we are exposing the exponents together, and that results in the following, where we, of course, we keep our base, but we do what? We multiply the exponents. So that means we're going to have our m to be multiplied by Rn. So see this as a distributive property where multiplying the n by everything that are exponents in the brackets. So that is what this means. Now here's an example of rule number 3, which says for the first one that we have 5 to the power of 2 all to the power of 3. So that is how this statement goes. And applying this rule here, we see that we have our parentheses and we have exponents that are in and outside. So that means that we are going to distribute our outside bracket exponent into the ones in the bracket, and that's the exponents. Therefore, what that results in is the following, which means that we're going to keep our base, which is 5, and our exponents we're going to multiply R2 by 3. And what this results in is the following, which is that we have our base, which is 5, and our exponents 2 times 3, which gives you 6. And so this here is our final answer, simplified form for this question. Now for case number 2, we have 2 parentheses here. So that means that they will work from the inside out, or you can say you're working from the outside in. So that means we're going to move the brackets on the outside first, and what that results in is the following, where we are going to keep the base, which we recognize to be -3, and what that results in is that our 4 is going to be now exposed to the 3, which means that we're going to be multiplying 4 by 3. Therefore, this here results in, don't forget that this here is going to be all applied to -3, and this results in the following, which is that is equal to -3 of parentheses, and the exponent here is going to be 12. So that is something to keep in mind when it comes to this scenario here, where you have a parenthesis and a parenthesis. So you need to take into account the outside parenthesis, remove that, and work your way inside. So keep that in mind for this scenario here. And here the final rules include the following, where let's say we have our bases to be C and we say B as the next base, that both multiply together and they're all to the exponent, which is in this case, let's say n. And so what this means is that we are going to be distributing our n to not only the B, which means that we are doing what in this case, multiplying by the exponent for B, but also we're going to multiply our n by the exponent for C. And so what does this results in? This results in the following, which is that we have our C to the exponent of what? N, and we have our B to the exponent of what? N as well. And take note that if B, for example, has an exponent which is m, we can multiply our n as the exponent on the outside bracket by the m on the inside bracket. So that still goes back to the third rule. So keep that in mind. And the final one here implies the following, where instead of multiplying 2 different bases or more bases, we are instead going to be doing what? Dividing the bases. And what that results in is that when we have our exponents to be n, we're going to distribute it as well to everything inside the bracket, both the numerator bases and the denominator bases. And what that results in is that we're going to have our n multiplied by the exponent for C, and we're going to have our n multiplied by the exponent as well for the B. And so what that results in is the following, which is that we have our C as the base, but its exponent is going to be what? N. And this here will be all over what? Our B, which is our base, but here our exponent for B is going to be what? N as well. So we're going to apply this here to the 2 examples that's going to be shown next. So in here are the examples here where we have 2 times 3 to the power of 2 all to the power of 4. And in here, for this particular step here, what we have to recognize is that yes, since we have our exponent on the outside, we're going to remove the bracket or parentheses and we're going to distribute it all in the brackets. So what that results in is the following, where our 2 as the base is going to be what? Affected by the exponent 4, and what that results in is that we have our base 2, and we're going to have, of course, initially we had our 1 as the exponent for 2, so that means 1 times 4. Remember that is what is happening here, and we're going to multiply this, of course, by what? 3 as the base, and our 4 as the exponent is going to be multiplied by the 2 for that exponent, and that as that exponent, therefore we're going to have our 2 times 4. Therefore our next step is going to be our base, keep it as 2, and our exponent is going to be to the power of 4, and we're going to multiply this, of course, by what? 3, which is the base, and we're multiplying our 2 by 4, which gives you what? 8. And so this here is our final answer for this particular question. And this here leads us to the 5th rule, which is now we are dividing two numbers here, and this here shows us that yes, we're going to do the same thing by removing the parentheses. We're applying the exponent on the outside, inside both the numerator and the denominator bases. Therefore what that result in is the following, where we have now base, which is 2, but remember that its exponent was 1, but now our 4 as the exponent is going to be multiplied by the 1. What that results in is that the base 2's exponent will be what? 1 times 4. And this here is going to be all over what? We have our 3, and our 3 here as the base has its exponents to be 2, but our 4 is also going to multiply by the 2, and therefore we're going to have our 2 times 4, and this here is going to be equal to what here? Our base for the numerator is 2, and we are going to the exponent of what? 1 times 4, which gives you 4. And then finally here for our denominator, we have our 3 as the base, but our exponent here is going to be 2 times 4, which gives you 8 as the exponent here. So this here is how you're applying our rule number 4 and rule number 5. Now we're going to look at some honorable mentions that you should take note when it comes to exponent. Honorable mentions, number 1 is that when you have any base, in this case here a, but we have our exponents to be what? 0. What that means is that our answer is always going to be equal to 1 as our answer. And how can you prove this? You can prove this, of course, by saying that, hey, to get 0, the base a must have an exponent to be what? In this case, m, and the other exponent as well must be what? Gotten from a base to be the same, which is a, and the exponent must also be m. So what that means is that we have a, keep the base, and you what? Subtract the exponent, m minus m, which means that this here is equal to a 0. But then if you look at it this way, whatever number of a's that you have above is also equal to the number of a's that you're multiplying below. Therefore, when you eliminate all the a's at the top and the bottom, it must always be equal to 1 by division, of course. Now another rule here to keep in mind is whenever you have a base and you have a negative exponent, let's say with negative m, what this means actually is that you are having what? The reciprocal of the base and exponent. So that is pretty much similar to what we talked about previously when you have this particular scenario where our m is less than n. Therefore we have our reciprocal that is generated. So this here is true here as well, because whenever you're in a scenario where you're going to be doing this particular setup, it always agrees or ends up becoming this particular general rule. So here are the rules to keep in mind in terms of the exponents. Let me know what you think anything that I missed in the comment section down below, or maybe a question that you think you need me to address in future videos. All the same, stay smart as always and believe in yourselves.